So now what we're going to do is we're just going to calculate delta H for a couple of reactions. So we'll do a combustion first of all, right? So we got 0.3 grams of acetylene combusting in a calorimeter. The calorimeter contains 8 grams of water at 27 degrees Celsius, so that's part of the surroundings. The empty calorimeter, in other words, what it would be without the water, has a heat capacity of 82 joules per degree Celsius. And so what we have there is the surroundings, the water and the calorimeter. Final temperature of the calorimeter, which includes the water, is 63. So then we're going to calculate the heat of combustion of the acetylene sample, so in other words the 0.3 grams that we have, and then we'll turn that into the molar heat. And of course specific heat of water, we're told 4.184 joules per gram per degree Celsius. So our system is Q of the reaction. As I said, can't measure that directly, so we're going to use the whole Q system is minus Q of the surroundings. Surroundings, as I said, is the water that is a substance and the calorimeter that is an object. So the Q of the water, it's a substance, mass times change in temperature times Cp. We've got 80 grams of water. Change in temperature, it ends up at 63. It starts at 27. And then the specific heat, 4.184 joules per gram per degree Celsius. So multiply all that out, and the water gets 12,050 joules. The calorimeter is an object, heat capacity times the change in temperature, heat capacity 82, change in temperature the same of course because it's the same as the water as part of the surroundings, ends up at 63, started at 27, so that's 2,952. So Q of the reaction is the total Q of the surroundings, so that's minus 12,050 plus 2,952. So Q of the reaction, in other words, this 0.3 grams of acetylene had a Q of 15 kilojoules. Okay, minus 15 kilojoules. It lost heat. We know that the system lost heat, the reaction lost heat, it produced heat because it warmed up the surroundings. So continuing on, the Q of the reaction, that 0.3 grams has a Q of minus 15 kilojoules. We want, however, the molar heat of combustion. Okay, that's the heat from 1 mole. Well, 1 mole of C2H2 is 26 grams. So we know 0.3 grams gives us minus 15. What's the heat from 26 grams? I believe the best way to do this is a ratio, right? In this case, we've got 2.6 grams, 26 grams. Gives us something we don't know, and 0.3 grams gave us minus 15. So put all that together, and the heat of combustion is minus 1300 kilojoules per mole. So now let's do a solution reaction. So we've got a solution of potassium hydroxide, strong base mixed with a solution of HCl, strong acid, and a calorimeter that has the heat capacity of 65 joules per degree Celsius. Okay, now the trick here with a solution reaction is that the water that's part of the surroundings is actually from the solutions. So we have 75 mils of water there, 25 mils of water there. Okay, and then we also got that in the calorimeter. So again, Q of the system is Q of the reaction. We don't measure that, can't measure that. The surroundings is the solution mixture plus the calorimeter. So let's think of the solution mixture. We have 75 mils plus 25 mils. Volumes are additive, so that means we have 100 mils. Density is 1, so 100 mils is 100 grams. Temperature change, it ends at 37 and it starts at 28. So the temperature change, 37 minus 28. And of course, this is water that we're heating up, 4.184 joules per gram per degree Celsius. So as far as the water is concerned, there is enough heat produced, 3,766 joules. Calorimeter, of course, is an object, heat capacity times change temperature, so that's 65 times 37 minus 28 is 585, right? 65 is the heat capacity. Again, the calorimeter starts at 28, ends at 37. So Q of the reaction is that all put together. So it's minus 3766 plus 585. So the Q of the reaction, minus 4,351 or minus 4.35 kilojoules. You know it's minus, you know it's giving off heat because the water and the calorimeter increased in temperature from 28 to 37. Now let's finish it off. Curator reaction was minus 4.35 kilojoules. Okay, now that was from the reaction that took place. We're interested ultimately in the molar heat of the neutralization. So we want to think about it per moles. So let's see what we actually had here. Okay, here's the reaction. Okay, of course it's a neutralization, but I'll just write everything out. So how many moles of KOH did we have? Well, 0.1 moles per litre times 75 milliliters, or 0.075 litres. So we had 0.0075 moles of KOH. We had 0.0025 moles of HCl, right? 0.025 litres times 0.1 moles per litre. So the HCl is the limiting reactant. So we don't care about the KOH anymore. We only care about the HCl. So 0.0025 moles of HCl gave us minus 4.35 kilojoules. We want to know what's the kilojoules associated with 1 mole of HCl. Best way to do that is a ratio. 1 mole of HCl gives us the delta H. 0.0025 moles HCl minus 4.35. Plug all that in, and the heat of reaction in kilojoules is minus 1,740 kilojoules per mole. Fun. Hope you enjoyed it. There are, of course, questions in the quiz.